Today is a special day, actually. It's really the end, so to speak, the final result that we can present of our doctoral school, Networked Autonomous Aerial Vehicles. The 4 students that were employed, particularly here in this program, they had tremendous work during these 4 years in the theory. They also did tremendous simulations, and they published in well-known, renowned journal and conferences. And now we brought everything to practice. So we're not in the ivory tower anymore. We really show that theory, then the simulation, and now the practice actually should work and will work, as I have seen before in the tests. So I'm very much looking forward to this event today, where everything comes together. All the 4 topics where the PhD worked so hard on finally can show what is actually bringing that theory, that simulation, into practice, into novel applications.
The next part is to be achieved,
So basically what you will see is a swarm of autonomous drones which are lying on the ground, and there are different objects that we place in the environment. These objects are boxes with teddy bears on top of it. And the idea is, as I mentioned, to do a 3D reconstruction of these objects. In order to do so, drones first take off, and this is actually the only non-autonomous part of the mission. So we, using remote controllers, we take off with them. That's why we need a safety pilot per drone. And after that, everything is completely autonomous. So drones, the only thing they know is where the objects are, so we give them the GPS coordinates of the objects. Then, once they are in the air, they have to agree on coalition formation methods. So they have to agree on who is working with whom. Different tasks require different number of robots. So you will see some tasks require only one drone, some tasks require 2 drones, some tasks require 3 drones. So they have to agree on first which tasks to do first and how many drones should go there. Then they divide among each other, they form coalitions, and then this was my part. And then they are assigned to these tasks. And then Agata's work takes over, and she is searching for path planning algorithms that will move them, navigate them safely through the environment without colliding. They have to reach the task, they have to form a pattern, a circular pattern around the task, again without colliding, using potential field methods. And then after that, once they are positioned where they should be, they are slowly rotating in order to capture many images from different locations of the same object. When they are done with that, they just send the flag, we are done, and then they can continue again with different coalition formation and task assignment methods, because there are still more tasks to finish in the mission. Michał's part is that actually once they are placed at the location, they start streaming the videos of this object, and the video streams that show the object have much higher priority than the video streams that don't have anything useful at the moment. Very useful for us at this mission is our objects. Once they are done with all the tasks, they just gather again and they land. And this is what we consider a successful mission. After that, Roland's part takes over, where he collects all the images captured of all the objects during the mission, and he builds 3D objects out of it. So he uses all the images, he applies different overlapping and 3D methods. He uses a software to get a 3D reconstruction of these objects.